All right, so welcome back. Today in this video, we're going to be looking at some pavement system design in the transportation engineering section of this Civil FE portion of the test. In this section, very important to note that you're going to have some prior knowledge. And so it's good that you're watching this video because what I'll be going over isn't necessarily in the FE manual. So let's go ahead and dive right in. All right, so number one says, what is the primary role of moisture content in influencing subgrade performance in pavement design? All right, so when we think of subgrade and when we think of pavement design, you have, I just want to give you a visual of what this kind of looks like. All right, so my blue is going to be my asphalt. And this is why I said prior knowledge is pretty key, because they're not really giving you this information. And then you're going to have subgrade. And the subgrade normally, depending on, what different types of soils you have, you may have two different types of, soils, and that's in red, right? And that's your subgrade. The blue is the asphalt. The subgrade is anything below that is soils, right? So, let's start out by going through our given fine formulas sequence. So what are we given? We're given, a question. We're not given any variables or anything. So this is kind of like not applicable. What are we trying to find? Well, we're trying to find the primary role moisture content of subgrade performance. Are there any formulas needed? In this case, not applicable. All right, so what's our answer? So A, the moisture content determines the soil type. No, I don't think that's the case. What about B? Moisture content affects the volume change characteristics of soil. So I know from geotech that actually is in fact true. Moisture content directly determines subgrade strength. Subgrade strength is a number of factors. It's not just the moisture content. It's also like things like compaction. There's a few different things that determine your subgrade strength. So I would say no to that. So nope. Moisture content has no significant impact on pavement design. I believe that it does. So just from picking answers, I'm gonna go with B. And I wanted to point out a few other things that is important when it comes to subgrade and how moisture content affects, things. So moisture content does have some impact. Moisture content affects the volume change characteristics of soil. So when you have high moisture, it can lead to swelling in expansive soils, and low moisture can result in soil shrinkage, right? Also, things to think about is excessive moisture can weaken the subgrade, causing like instability and settlement issues. And then proper drainage measures are necessary to maintain moisture levels and prevent, detrimental effects on your pavement performance. So just some extra things to kind of keep in mind if you're given some conceptual questions on this exam when it comes to pavement systems design. All right, so let's look at number 2. Number 2 says, which factor significantly influences the thickness design of rigid pavements for highways with heavy truck traffic? Heavy truck traffic. Okay, so A, jointing systems. Don't know what those are. Jointing systems sounds like joints from maybe structures, something, or bolts or something, but don't think that's the right one. Compressive strength of concrete. No. Traffic loading configuration. Maybe. And environmental conditions. Maybe. Okay, so what are we given? Nothing. So this is not applicable. We're trying to find the factor that significantly influences thickness design. So and so between environmental conditions and traffic loading configuration, the more traffic, the heavier the loads. I think that's going to influence how thick that design of your asphalt needs to be, right? If you have a ton of trucks and a ton of different axles going across, your asphalt, it's going to create a lot more problems if it's weak, right? Or it's really thin, right? So you're going to need it to be thick enough to handle all that constant amount of traffic that's coming through. So I'm going to go with C. Just some other things to point out. The configuration of traffic loading, including axial spacing and wheel load distribution, affects how loads are transmitted to the pavement. So important thing to keep in mind. And then a pavement design accounts for different loading configurations to ensure that the pavement can withstand the specific loading patterns imposed by heavy trucks. So just some extra things to keep in mind as you're doing pavement design. All right. Let's look at number 3. So number 3 says, how does poor drainage impact pavement systems and their longevity? All right. So what are we given? It's not applicable. What are we trying to find? Basically, poor drainage impacts and how it impacts pavement systems and how long they're able to last due to poor drainage, right? So are there any formulas needed? Not applicable. So let's look at our choices. So A, it enhances surface water flow, reducing the risk of hydroplaning. So I don't think poor drainage within a pavement, that means water stuff is kind of built up is going to enhance your surface water flow and keep and reduce the risk of hydroplaning, right? So that it prevents erosion and maintains stability, leading to improved pavement performance. Don't think that's one. Preventing erosion when there's a lot of water that's involved in the pavement systems, I don't think that's going to be the case. It minimizes the risk of frost, heave in cold climates. Well, if you have water sitting on a pavement, right, and it's cold, it's not going to prevent frost. So water sitting in cold temperatures on a road is not good, right? And so it can lead to subsurface saturation, weakening the pavement structure and reducing its lifespan. Yeah. So anytime you have poor drainage, it's going to cause normally problems. It's not going to help anything. All right. So this concludes our highway pavement design section. In the next section, we'll be looking at traffic capacity and flow theory.